Okay, so let us continue our lesson. We talked about a little bit of motivation about differential equations. I told you that whenever you actually want to do something practical, you have to somehow translate the laws of your nature, or the laws of your model in the language of differential equations. So that's an extremely important part of mathematics, to be able to solve differential equations. You will study a lot of it, actually. You will have courses on this in university, but let us now start at least the very simple concepts here. So let me just refresh you a little bit. So a differential equation, I told you, is an equation in which a function is unknown, and in that equation you see derivatives of that function. At least one derivative of that function is also involved, and then the order of the derivative, the order of the highest derivative, is called the order of the differential equation. For example, if I want to write some differential equations for you, so here I can write y double prime plus x squared y prime is equal to sine x. So that's a differential equation. So here, your function, which is not known to you, is the y function. Y is your dependent variable. X is your independent variable. So that is a differential equation. Writing a differential equation is very simple, but solving it is a whole new, actually, topic. Okay, so this is a differential equation, and if I ask you what is the order of this differential equation, you see that there are two derivatives involved. This one is a second order, this one is of the first order. So the order of this differential equation is the order of the highest derivative that appears. So that's a second order differential equation, yes? And if I can find y, so that if I plug it here and calculate the left-hand side, it becomes identical to the right-hand side, that y that I find, which is a function, is called a solution to this differential equation. But the general solution is a solution including as many free parameters as the order of the differential equation. So if I want to solve this differential equation in general, you should expect two free parameters in the solution. If that's the case and it satisfies the equation, that is called the general solution. Okay. Sometimes differential equations are written in Leibniz notation. So, for example, this d3y, I don't know, dx to the 3. Do you remember? This is another way of writing the third derivative. And then you have, for example, plus 4x times dy dx to the power of 2. And then you have equal to dy times d squared y dx squared. And I don't know, for example, e to the power of y. So that's also a differential equation. And the order of this differential equation, so here the order was 2, and here the order is the highest derivative that appears, and that is equal to 3. Yes? For example, let us consider this differential equation. So y double prime plus omega squared y equals to 0. This is more or less the same equation we considered last time. But here, for example, y equals to, so let me make it simple here. We talked about this omega before, so let me just write it for y equals to 0. And here I can ask you to show that cosine of 2x here is a solution to this differential equation. How should I check that? I need to convince myself that this will satisfy this equation. Yes? So what I do, I need to take the derivative, so it becomes minus 2 sine 2x. And I need to take another derivative, so it becomes minus 4 cosine 2x. Then I will start from the left-hand side. Instead of y double prime, I put this. and plus 4 times y, which is 4 times cosine 2x. But I hope that you agree that this is gone. It becomes 0, and the 0 is the right-hand side. Yes? So this is a solution. But we cannot consider it the general solution. Yes, I can have another solution. If you remember, I can also start from here. Y equals to, let us say, 5 sine 2x. That is also a solution for the same differential equation. Let us check. What I do, I take a derivative. So it becomes 10 cosine 2x. And I take one more derivative. It becomes negative 20 sine 2x. And then I again start from the left-hand side. Instead of y double prime that you see there, I put minus 20 sine 2x, and then plus 4 times y, which is 4 times 5 sine 2x. Then again, minus 20, and this becomes also 20, so then it becomes 0 again, and that is exactly equal to the right-hand side. So you see that I have got two solutions here. So one of them is this solution, the other one is that solution. But none of them is called a general solution, yes? Because if I ask you how many free parameters you see, x is your dependent variable. No, independent variable. Y depends on x, so y is a dependent variable. But except for that, you have a constant. You don't have any other parameters involved. But so this is not the general solution. The general solution of this is expected to have two free parameters. Okay. So for example, if I ask you to show that a sine 2x plus b cosine 2x, where a and b are arbitrary constants, so it means that now I have two free parameters. Yes. In this equation, in this function, I have two free parameters. If I can show that, regardless of the values that I choose for a and b, this function satisfies that equation, so I have two things. First, I show that this is a solution. Then I see that I have two free parameters, and the order of the differential equation is 2. So then it means that that is the general solution. So to prove that that is something is the general solution, first of all, you need to show that that is a solution, regardless of the choices of the parameters, for all choices of free parameters. This is the first step. And then the second step, you need to show that, you need to say that, okay, there are two free parameters, the order is 2, the order 2, and then they match, so that is the general solution. So let us check if this is the general solution or not. What I have to do, I have to take the derivative of this function. So this becomes what? 2a cosine 2x. This becomes negative 2b sine 2x. This is the first derivative. The second derivative, it becomes negative 4a sine 2x, negative 4b cosine 2x. Yes? And then I start from the left-hand side again. What can I do now? I have y double prime 4 times y. Instead of y double prime, I put this, so it becomes minus 4a sine 2x minus 4b cosine 2x. And then plus 4 times the starting y. This is my y. So I multiply it by 4, so it becomes 4a sine 2x plus 4b cosine 2x. But you see, it doesn't matter what the value of b or what the value of a is. This is cancelled with this one for all possible choices of b. And for all possible choices of a, these are also cancelled. So what is left for me is 0, and what that 0 is, this is the right-hand side. So it means that regardless of the values that I choose for a and b, for all possible choices of a and b, this satisfies the equation. So it is a solution. And then it contains two free parameters. The order of differential equation is 2, so 2 is equal to 2, so it means that this is the general solution. Yes, is that understandable? That's a very simple concept. Okay, so let us. So let me solve some more problems here for you. Sometimes they ask you to find a solution that satisfies some extra conditions. Yes. So, for example, they can ask you this. They can ask you. Let me write it. This is the terminology that we use. It's exactly like the physics lesson we just learned today. So, example. So these terminologies I want you to know. Solve the following initial value problem. So let me write IVP for short, okay? So what do I mean by initial value problem? Initial value problem is a differential equation together with some extra conditions that you impose on the differential equation. Okay, so for example, I say that we usually write it in the curly brackets. This is my differential equation, and I demand that y of 0 be 0, and I demand y prime of 0 is equal to 1. Okay, so I just want you to understand this notion. So this is called initial value problem. There is another type of problem is called boundary value problem. Yes, an initial value problem is it means that you give me a differential equation and you give me some extra conditions on that differential equation, but they are calculated at the same point. Yes, if I give this one at 0, I have to give this one at 0. If I respect that, then this is called initial value problem. But might be I give you y of 0, but might be I give you y of 0 is 1, and y prime of pi over 2 is, I don't know, is 2, for example. Then you see that I am giving one condition at 0 and the other condition at pi over 2, and they are not the same thing. Yes? In those cases, we call them a boundary value problem, not an initial value problem. These are the terminologies we use. So whenever I say initial value problem, it means that you should expect to give you some extra piece of information. Both of them are given at the same point. By the way, I don't need it. So usually this is the case. They give us an information about the function. They give us an information about the derivative, the first derivative. But it doesn't necessarily like that. You can say y of 0 is 0, but you cannot say that, by the way. You see, if I say y of 0 is 0, then I cannot say y of 0 is something else, yes? So in the boundary value problem, in the initial value problem, because I have to respect that these two things are the same, I have to change it some way, yes? So I put prime here. But in the boundary value problem, it might happen this way. So let me solve them one by one. Don't get confused. Okay, so you want to solve this initial value problem. So I informally define this, what is the meaning of initial value problem. So it means that I am not interested in all solutions. I am interested in a particular solution which also satisfies these conditions. That's why it is clear. I find the general solution. Here you check that this is the general solution. Later, of course, this is beyond the scope of your lesson. But if the solution is given to you, so you can realize that we can say that we saw that this is the general solution. B 2x plus b cosine 2x. This is the general solution. How? By inspection, we realize that this is the general solution. But now I want to choose A and B so that this function, which is the general solution, satisfies these two conditions as well. So it means that y at 0 should be 0. What does it mean? It means that if I replace x with 0, the answer is supposed to be 0. But when I replace x with 0, this is sine of 0, which is 0. So it means b is 0. Yeah, if you don't understand, please let me know. Do you understand that y b is 0? Yes, y at 0 is supposed to be equal to 0. It means that when I replace x with 0, the answer is supposed to be 0. This can only happen that if b is equal to 0. Yes? And then the next condition tells me that y prime of x, let me calculate y prime of x. So y prime of x is 2a cosine 2x minus 2b sine 2x. Okay, and then y prime of 0 is supposed to be 1. So this means that if I replace x with 0, the derivative should be equal to 1. So if I replace x with 0, this becomes 2a is equal to 1, and a becomes 1 over 2. And now the answer that you need to provide is this function, y is equal to, instead of a, you put 1 over 2, so it becomes 1 over 2 sine 2x, and instead of b, you put 0. So this is what you need to provide. What does it mean? It means that I was able to find a solution for this differential equation, but on top of that, this solution satisfies these two conditions simultaneously. So this means that I have solved this initial value problem. Yes? For example, let me just, if you want to have it in your notebook, so let me just do the same thing for a boundary value problem. Here, I just want you to understand what is the meaning of initial value problem and boundary value problem. So I can write it here down for you. So example, solve the following boundary value problem. Boundary value problem. So let me write it BVP for short. Yes. I just want to play around with the same differential equation. I'm just using this as an excuse to teach you these words. Okay, so this time, instead of writing this, let me write it in this way. So I don't know, pi over 4 is equal to 1, and y of, so I don't know, pi is equal to minus 2. I can choose to give one of them as the derivative. It doesn't matter. But I hope that you understand this is not an initial value problem, because one of the information is given at pi over 4. The other information is given at a different point, which is pi. So we want to calculate this. So again, you already know you have the general solution. So the general solution is a sine 2x, b cosine 2x. But now what I have to impose is that y at pi over 4 is 1. So it means that if I replace x with pi over 4, so it becomes a times sine 2 times pi over 4 is pi over 2, and then plus cosine pi over 2. This is supposed to be equal to 1. I replace x with pi over 4. And then sine of pi over 2 is 1. So this becomes a, and the other one is 0. So a is equal to 1, because cosine of pi over 2 is 0. So I got a. And I have to impose the other condition. So y of pi is equal to minus 2. So it means that if I replace x with pi, what happens? So this becomes a sine of 2 pi plus b cosine of 2 pi is supposed to be equal to minus 2. But sine of 2 pi is 0, cosine of 2 pi is 1. So it means that b is minus 2. And then what you have to provide for this boundary value problem is y equals to sine 2x minus 2 cosine 2x. Yes? So remember that if you have a derivative, a differential equation of order n, then you have n 3 parameters in the general solution. if you are supposed to come up with exactly one solution, they have to provide you extra pieces of information. How many of them? N of them. Yes, because you will have n. If this is order n, you will face with n arbitrary constants. To fix all of them, you need n extra conditions. So you need to have n extra conditions. Okay, this is something that I want you to know about these words: boundary value problem and initial value problem. And now let me today I want to solve you 4 problems, and I think it would be good. Or let me start with an example first, a simple one. All of them are at this level of simple, because the hard part of differential equations is how to solve them. Yes, we are not solving here. We are guessing more or less. Yes. Okay. So this. Let me, for example, give you this. Show that y equals to ax cubed plus b over x is a solution. So let me write it in this way. For all real numbers a and b, is a solution to the differential equation, to the DE differential equation, x to the power of 2 y double prime is equal to xy prime plus 3y. Of course, if I want to be explicit, I should write on any interval. On any interval not containing 0. Yes, why? Because it is clear that if the interval contains 0, my function is not even defined there. So how can it be differentiated? Because, by the way, these are tricky things. If you want to plug this function here, it means that y prime should exist. Yes, and y double prime should also exist. If the function is not defined, the derivative of the function is not defined either. Yes, so for having this, x shouldn't be equal to 0. Okay, and then okay, now the question is this solution the general solution? Okay, using this, solve the following initial value problem. The initial value problem is this. You have your differential equation. Okay, so this is a typical question, a typical format, which is of course very simple. You need to be able to solve these type of problems for this chapter. Again, you see that this differential equation, I will consider it a non-trivial differential equation. It is not that easy to come up with that answer. Yes. So, but the answer, when the answer is proposed, confirming that that's the answer is easy. But coming up with that differential equation is not that easy. This differential equation is called the Euler differential equation. So Euler is ubiquitous everywhere, so you can see track of Euler everywhere. And it is not, by the way, that hard to guess this. We can come back to it. Let us not confuse. So let us confirm everything. We want to show that this is a solution for this for any choices of A and B. So that is an easy task. So what we have to do, we have to differentiate 2 times of the function the first time. So, but you know that it is better to avoid the quotient rule if possible. I usually prefer to avoid quotient rule if possible. So this is why, instead of starting differentiating right away, I just change the form a little bit. I would write ax to the 3 and bx to the negative 1. Yes? And now I start differentiation. So y prime is easier. You see, it is 3ax squared. And then minus bx to the power of minus 2. I don't have any problems in differentiation in this form. I can even do a lot of differentiations now. So this becomes 6ax plus 2bx to the power of minus 3. So remember this trick, yes? Okay, now what I have to do, I can calculate the left-hand side here. I can calculate the right-hand side and compare the answers, yes? So here I have to multiply x squared by my y double prime. So what happens? It becomes x squared 6ax plus 2bx to the negative 3. And I multiply this side, so it becomes 6ax cubed plus 2bx to the power of minus 1. Okay, now I have to calculate the right-hand side. But the right-hand side is x times y prime. I have already calculated y prime. And then I add 3y to it. Yes? So you see on the right-hand side, I have x multiplied by y prime. I substitute that expression for y prime. I substitute y for this. And this is my expression. So let me multiply these things. So it becomes 3ax cubed minus bx to the negative 1. And then I have 3ax cubed. And then plus 3bx negative 1. So this 3ax cubed, this one, it becomes 6ax cubed. And then I have minus 1 of them with 3 of them. So it becomes 2 of them. So if I give this number 1 and I give this number 2, you immediately realize that the left-hand side is equal to the right-hand side. So therefore, for now, comparing number 1 and number 2, I can conclude that left-hand side is equal to the right-hand side. Okay. And you see that this calculation is completely independent of the values of a and b. Whatever a and b are, the left-hand side is equal to the right-hand side. If, of course, x is not equal to 0. Okay, is this solution the general solution? Do you think the solution that we confirm it's the solution is the general solution here?
Yes.
Yes, why?
That the number of free parameters is the same as the highest order.
Exactly. So that's the order. The order of if I ask you what is the order of this differential equation, you would say 2 because the highest derivative appears there is 2. And then how many free parameters you see there? It's a and b. So there are 2 free parameters. So yes, the answer to this is yes. Okay, using this, solve the following initial value problem. So it's very simple. You see, this is the same differential equation, but I have imposed 2 extra conditions on that. So it is because of you want to fine-tune a and b. So what I have to do? I would start from this differential equation. So sorry, I have to start with that answer. Okay, but then I know that y at 1 is supposed to be 2. So what does this imply? This implies that if I replace x with 1, the answer is supposed to be 2. So if I replace x with 1, then I will have a plus b is equal to 2. That's one equation. And then I have another condition that is imposed on the derivative. Derivative is already calculated here. So let me write it in a nicer language. So this becomes 3ax squared. And I would write minus b divided by x to the power of 2. Yes? And now what I do, I would say that y prime at 1 is supposed to be minus 6. So what does it mean? It means that if I replace x with 1, the answer is supposed to be minus 6. So it becomes 3a minus b is equal to minus 6. And then I solve this system. A plus b is equal to 2. 3a minus b is equal to minus 6. So for example, I add these two equations, these are gone, so this becomes how much? A is minus 1 and b is 3. Yes, so that is the solution. And then the answer to the initial value problem is a unique function. So it is y equals to, instead of a, I put minus 1, so it becomes minus x cubed, but plus b, which is 3 over x. Is that understandable? So that's a typical question, a very simple question. But if you were Euler, you wanted to discover this function, do you think you can do that somehow by looking at the differential equation? So here, the general solution was proposed to us. We just confirmed that. So that you want to come up with the same solution, what type of function would you imagine that might be suitable here? Yes. For example, do you remember we talked last time? You come up with the answer of exponential function. It was completely correct except the minus sign. Then we realized that might be sine and cosine functions are good. But could you come up with a guess for this differential equation, a type of function that is useful for this? Yes?
It should be, what is it?
You don't need to name it. You just call it whatever you like.
Third power equation? Or
No, not third, because how do you know that this should be third power? Is it clear it should be third power? Yes? Because you are saying that to be honest, you might be right, but I was thinking it should be a polynomial function of that type, but I don't exactly know. Should it be 3? You are somehow right. But what I'm trying to say is that if I have a function of this 4, x to power r, what happens? If I differentiate it, I will get a factor, but the exponent becomes 1 unit less. And if I multiply it by x, it becomes exactly of the same type, x to the power of r. And if I differentiate it 2 times, 2 factors r and r minus 1 goes down, but then I will have r to the power of minus 2. But then when I multiply it by x squared, then it will go back to y x to the r. So what I would say is that by this kind of thinking, I might be suspicious that might be one solution of this differential equation is of this type. Might be, we don't know, because of this way of thinking. If that is the case, so let us see. This is just an educated guess based on that observation. Now we say that let us see, can I fine tune this r so that I can have that equation? Let us do that. Let us put this into that equation. By the way, this is called, I think this is German word, Ansatz. I don't know this, but this is what we call in mathematics. I think it's a German word. That is called Ansatz. Ansatz means that somehow I can understand the form of the function, but not on all the details. Yes. So here, this is not completely clear because r is still missing. But based on that argument, I might come up with this idea that one possible, might be not true, but one possible answer for that differential equation should be of this form. This is called ansatz. So we put it back into this equation to see if our ansatz is actually correct. So how we do that? We put it back into that differential equation. So let me just do that. What is y prime? Y prime is r, x to the power of r minus 1. And then y double prime is r times r minus 1, x to the power of r minus 2. And then let me put it back into that equation. So then it becomes x squared multiplied by r minus 1, x to the power of r minus 2. Yes. On the right-hand side, it becomes x times x to the power of r minus 1. And then finally, 3 times x to the power of r. Because the reason that Sanders tells me that it should be power 3, because that's not exactly power 3. There is another power minus 1 as well, which might be we were not able to guess. Okay, but now you see that. So by that kind of reasoning, I just want you to see these things. You will study them systematically later. Okay, but this is not hard. This is at the level of your knowledge. It was probably not that very hard to guess that this might be the form of a function that satisfies here. And then I take this ansatz, I put it back into this equation, hoping that I can find r. It might happen that this is not possible, so I need to throw this solution away. But this is one trick, by the way. You will learn that in the future. This is a trick for solving these kinds of, some of the type of equations. Okay, so let me see what happens. This becomes r squared minus r. X squared multiplied by that, it becomes x to the power of r. And then this becomes r, x to the power of r again. And this becomes 3x to the power of r. So let me divide everything by x to the power of r. Then it becomes r squared minus r is equal to r plus 3. And this is just a simple quadratic equation. So it means that if I can satisfy this equation, I can go back. So it means that this would be a solution. But how should I solve this equation? It's simple, yes? So I would write r squared minus 2r plus minus 3 is equal to 0. You can use ABC formula or PQ formula. You find these answers. So the answer would be minus 1 and 3. So actually, if r is minus 1, this ansatz is correct. It becomes x to the power of minus 1, which is 1 over x. Yes? And if r is 3, you get y equals to x to the power of 3. So actually, by this method, this means this. If this is going to be a solution for the differential equation, is it possible for such a function to be a solution to the differential equation? Yes. How many choices of r I have 2 choices for r. One of them is 1 over x, and one of them is x to the power of 3. And then if you go to the theory of differential equations, this is a linear differential equation. If you have time, I will talk a little bit about these things. A linear differential equation has this property that if you find 2 solutions, if you multiply this by any number, multiply this by any number, and add them together, still this new function is a solution. Okay? It's not hard to check these things. So this is why you see they have multiplied the first one by a and the second one by b, and they have added together. So that is the general solution. Yes. So if you have two independent means none of them is a multiple of the other. These 2 functions are totally different. This is not a multiple of that. If I have 2 independent solutions for a linear differential equation of the second order, then immediately I can write the general solution. That's a theorem in mathematics. So I just want you to see that it was not that hard to guess at least some solutions. Yes, might be x to the power of 3 was easy because you were able to guess it, but the other one, x to the power of minus 1, was a little bit tricky to guess. But this is one way to deal up with that. Is that not okay here? Understandable? Okay. But now let us concentrate now on a little bit harder problems to actually calculate. Okay, so that's it. I'm just increasing the level of mathematical calculation. Next time we will talk a little bit more about other types of methods of solving differential equations. There's only one differential equation that you need to consider at the level of your lesson. Okay, so let me ask you to do this. Where is this? Okay, so let me write with different language. Usually differential equations in physics and engineering, the independent variable is time. Okay, so let me just write it in this language. Show that x of t equals to a e to power minus t sine t plus b e to power minus t cosine t is a solution let me write, is the general solution to the following differential equation. So let me write it in Leibniz notation so that you can get used to these different ways of writing things. So using that, solve the following initial value problem, IVP. Okay, so that is actually an easy task again. Again, the hard part is that if someone gives you this equation, how you should find that solution, which is not that easy at all here. And it's also a famous differential equation, so you will learn about that later. So in differential equations, actually is important for all branches of mathematics, physics, computer science, electrical engineering, so whatever you need. Whatever you study, you need calculus and differential equation, that's minimum. Okay, so what I have to do, first of all, I hope that you are not confused. Here, this x plays the role of y, and this t plays the role of t. Yes? Sorry, this t plays the role of x. So here, I need to use Leibniz notation. So dx dt, I have to calculate. Okay, so how should I calculate this derivative of this x? Remember, there are two product rules involved. So this is a lot of calculations, so let us just do it patiently. So a product rule for the first term, a product rule for the second term, yes? So the product rule for the first term gives me minus a e to power minus t sine t plus a e to power minus t cosine t. Can you confirm this? What I have written for the first part is correct? So I'm using the product rule for e to power minus t and sine t, yes? The derivative of e to power minus t is minus e to power minus t multiplied by the second function plus the first function multiplied by the derivative of the second function. Yes? Yeah. And I continue for the next one. For the next one, what will happen? It becomes minus b e to power minus t cosine t and then minus b e to power minus t sine t. Yes, I wanted to confirm that. Yes, check my calculations. Don't rely on my calculations. Do you agree?
Yes.
Hopefully. So let us do another one. Because now we are in trouble. Product rule, product rule, product rule, product rule. Yes? So so let us just do it in our head. So it becomes E. Can you confirm that one as well? Please check. Is it confirmed? So this is, if I am supposed to write this for this part, I'm supposed to write this for this part. No. So it is not complete yet. Yes, so I completely messed up, sorry. Let me double check myself. So this is what? This is correct. This is correct. This too is for this one. And then when I come here, this is correct. Yeah, this one is correct, yes. But then suddenly I went here. That is correct. So yeah, I was confused a little bit here because I just dropped the last one. So this one is this, and then it becomes positive b e to power minus t sine t, and then I go there. Then it becomes plus b e to power minus t sine t minus b e to power minus t cosine t. Okay, so let us check. Everything is right. So this term, these two terms, if I am right, I am writing it for here. Let me double check this one. The derivative of this one is positive, this is correct, and then that one. So that is correct, so that is only one middling I have to check. This is negative, negative, positive, positive. So it seems it's correct now. Do you agree? Can I simplify this? In the above one, I cannot simplify anything, yes? Or can I? Yeah, let us keep it like that. But here, can I simplify something?
You can simplify.
You mean factoring out? If you mean simplify that, yes?
Yeah. Yes.
Okay, that's a crazy question, but
Then to do like 2b e to the power minus t sine t.
no, if that is the case, yes, that should be nice. But this is not the case, at least in this one, is it?
I think the first term and fourth term.
You can pull something out, yes? But you cannot simplify that. Because this is A, this is B, yes? So let us keep it like that.
But can't you like collapse that and just write 2b e to the power of minus t sine?
Where?
Last line, for instance.
Here,
Yeah, two positive signs. So.
here,
Yeah, and then to the left.
which one and which one? A e to power minus t sine t. Do I have this combination? E to power minus t sine t. This one and that one can be simplified. Yes. And here e to power minus t cosine t. Do I have that combination with a? Yes. This one and this one. So you are right. If I have done it correctly, yes. Let's pray. So that is correct. So let me get this one and this one. So this one and which one and
The last one.
the last one, they are gone. Am I right? And then these two will be added, yes? Yes, at least if I have done my derivatives in a right way, this is definitely the correct derivative. But it is a little bit strange because the second derivative is a little bit more compact than the other one. Let us see what happens. Okay, now I will start from the left-hand side. So what is the left-hand side? The second derivative is this one, if we are right. And then I have to multiply the first derivative by 2. I need to multiply everything here by 2. So it becomes minus 2a e to power minus t sine t. I multiply that. And then minus 2b e to power minus t cosine t. And finally, minus 2b e to the power of minus t sine t. Agree? So that is up to here. Then I have 2x. So I have to multiply my x by 2 and add it here. So this becomes 2a e to power minus t sine t, and then plus 2b e to power minus t cosine t. Hopefully, if I have done everything right, everything should vanish because I have to reach to 0 on the right-hand side. But do you think it is the case or not? Does it look like that? This one is cancelled with something or not? Yes, at least this is cancelled with that. So minus the first one and
The 4.
this one. Yes, that's also cancelled. The other one, this one with that one. Yes. And then finally we are lucky. So the calculation was apparently correct. Yes. So yeah, that's easy. Even though this is a complicated differential equation, even if you see it's not hard, even though it's a little bit tedious, but the task is very simple. This is mostly what you need to know at the level of this lesson, which is of course a little bit boring, I understand, but that does improve our differentiation skills. Okay, and then use that to solve the following initial value problem. Okay, so if I want to solve the following initial value problem, what I have to do, I know that x at 0 is equal to 1. So x at 0 is equal to 1. So can you immediately tell me what can I decide about a or b in this case when x of 0 is 1? Yes, what does it mean? It means that when I replace t with 0, the answer is supposed to be equal to 1. So what does it mean? You can immediately calculate either a or b.
B is 1.
B is 1, yes? Because if I put 0 instead of t, the first term completely vanishes because sine of 0 is 0. But if I put 0 here, cosine of 0 is 1, e to power 0 is 1, so it becomes b. So if you ask me what is x of 0, I would say x of 0 is b. And then it is equal to a. It's equal to 1. So b is equal to 1. Yes? And then what I have to do, I have to use the other condition. Unfortunately, I have it here. This is x prime at t. So x prime at 0 is supposed to be equal to 1 again. So it means that if I go to the derivative and I replace t with 0, this will vanish. This also vanish. And then this becomes 1, which becomes a. And this also becomes 1, which becomes b. So it becomes a minus b. So a minus b is equal to 1. But I already knew that b is equal to 1. So a becomes 2. So what you need to answer for this part is x of t is equal to 2 e to power minus t sine t plus e to power minus t cosine t. So that would be the answer to this initial value problem. Yes? Yeah, we can solve 2 more problems. So one problem I want to emphasize again here. So any questions here? Okay, so let us get rid of that. Let me write this one for you. Show that, so example, this is mostly math 4, not 5. Yes, because I want to check your differentiation skills. So show that y equals to sine of pi times the square root of x plus 1 is a solution of the following differential equation. is a solution to the following differential equation. The differential equation is a little bit, so 4x plus 1 y double prime plus 2y prime is equal to minus pi squared times y. Okay, so what we have to do a lot of calculations apparently. The first derivative is not hard, but might be the second derivative becomes problematic, yes? And you see that, because when you do the first derivative, by the chain rule, the derivative of the argument becomes something with fraction. And then we have to use chain rule and the quotient rule simultaneously for the second derivative, yes? So let us check that. Okay, tell me, what should I write? Okay, you can help me now because you're Simon. So what is y prime? What should I write? Can you tell me?
Cosine.
What?
Minus cosine of the contents times the derivative.
No, minus. Why do you say minus?
Oh, it's cosine. Yes.
Yeah, cosine of what? Cosine of
Pi times.
pi times square root of x plus 1, then? So do you remember, this is a very serious part of your education. You need to know it very well. The chain rule. So what is the answer? I need to complete it with what? Derivative of what is sitting in front, yes? So it becomes, let us just do it step by step to refresh your memory as well. That is the chain rule. And then pi is just a constant, so I can pull it out. But do you remember what is the derivative of the square root here?
1 over
Yes?
2 times the square root of
X plus 1. But again, by the chain rule multiplied by x plus 1 prime. But x plus 1 prime is just 1, so let us not write it down. In principle, I have to multiply it by this because of the chain rule. But because the derivative of this expression is 1, I don't write it down. So if you don't mind, let me just write it in a more appropriate way because the hard part starts here. So I have a pi, I have a 2, so let me write pi over 2. Then I have a cosine, pi square root of x plus 1. And then I have divided by square root of x plus 1. So this is my first derivative. Yes? So our prediction was correct. So we now have the chain rule and the quotient rule simultaneously. Okay, so how should I do that? Do you remember the quotient rule formula? You have to remember. These are very famous ones. So what is the derivative of f over g prime? Do you remember?
f prime times g minus f times g prime over g squared.
Exactly. That is the quotient rule. So I have to use this one. So now this pi over 2 is nothing. So if you don't mind, let us just keep it there. So if I wanted to calculate y double prime, I put pi over 2, that's a constant. Now I write it here. The derivative, let me be patient and write it patiently. So the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator. The denominator to power 2. So let us get rid of that square root sign. Agree? So this is so far. But I have to be patient. There are tedious calculations. We have to be sure that we are not missing something. So if you don't mind, let us just keep this pi over 2 here. So y double prime is, and then I can, by the way, because this is already done, so let me put it next to 2 here, because I don't need to do anything with that. So it becomes pi over 2. Yeah, I don't want to be tight with taking a lot of things with me unnecessarily, yes? So then I open a pair of brackets. So you see pi over 2 and this one, I combine them in one place. I don't care about that. I care only about this point. Yes? This I don't have any problem, by the way. Do you see? This is exactly what I did in the beginning. Yes? So the answer that you get here is just the derivative of this part. Do you agree? Because do you remember I started, oh no, sorry. I started with sine. That was a very big mistake, sorry. So now let us just do it. Unfortunately, we have to do it from scratch. So what becomes the derivative of cosine is minus sine. Yes. But multiplied by the derivative of this, which gives me, let us not repeat that, which gives me minus a pi, and then divided by 2 square root of x plus 1. Do you agree? I hope that you are not confused. It's exactly the same story, but I started with sine. I ended up here. Today, right now, I am starting with cosine, so it is clear I will end with minus sine. Yes, but now the good point is that I am supposed to multiply it by an extra square root of x, which will cancel that one. So that's not that bad. Yes, and then this one is just a normal function, and the derivative of this, you just mentioned it, that's this one. So more or less we are done. It's not that hard. So let me get rid of this now. So this becomes minus cosine pi square root of x plus 1. And then I multiply it by 1 over 2 square root of x plus 1. Okay, so let us have a rest to see if this is correct. Do you see any flaws in my writings, anything? Yeah, it seems to be correct, yes. Okay, and then, so what we can do? For example, you see that I can pull this, I can simplify this one with that one. Okay, so what is y double prime? So y double prime is this. So you see that I can, what can I do? I can pull a minus sign out, so it becomes minus pi over 2 x plus 1. And then, what do I have here? I have a pi over 2. A pi over 2 because I put the negative sign out. And then sine pi square root of x plus 1. That's it. And here I have plus cosine of pi square root of x plus 1, and then divided by 2 square root of x plus 1. Yeah, please watch my calculations. So this is y double prime. Yes? Is there any flaw here? Okay. So apparently we cannot simplify it more than that. So the hard part starts. Hopefully we can do it. So I start from the left-hand side to see that if I can get the right-hand side. So the left-hand side is equal to. So I have to multiply y double prime by this factor. So can you do it in your head? If you multiply 4 by x plus 1 here, that x plus 1 that I am multiplying will cancel this x plus 1. Yes? And this 4 that I am multiplying, with these 2, it becomes minus 2, which I multiply in the numerator. So it becomes minus 2 pi, and then the rest of it. Yes? So do you agree with me now? I multiplied y double prime by this. Then I need to add, to multiply my y prime by 2. Y prime is here in front of me. I multiplied by 2. That 2 will cancel. This 2 pi is left. So I would write plus pi cosine pi square root of x plus 1 divided by square root of x plus 1. Yes? So this is 2y prime. Now let us simplify this expression. Do you think it is hopeless or hopeful? Yeah, do you think that there's something going on? Let us multiply. Minus 2 pi multiplied here. What happens? This 2 and that 2 are cancelled. Pi times pi becomes minus pi squared. And this expression yes? And then I multiply minus 2 pi here. 2 and 2 are cancelled, so it becomes minus pi cosine pi square root of x plus 1 divided by what I did. I multiplied that, so it is a square root of x plus 1. Yes? And then I have this one. Yeah, we are done actually, so yeah, good. So this becomes cosine pi squared. These are cancelled actually. So I was worried a little bit about my calculation here, but this is correct. So yeah, I want to wait for you. Do you catch up with me here now? Yes. So what I have done, I multiplied this by 4. This is the first part. I multiplied y prime by 2. This is that one. And then I multiplied this inside. And then I add this one here. But the good point here is that this is fortunately is exactly equal to this, and that is gone. So what is left for me is just one single term. It's minus pi squared sine pi square root of x plus 1. Do you see that we are done or not? Yes?
Yes.
We are done because minus pi squared is minus pi squared, and what is in front of pi squared is just y. So this becomes minus pi squared y. And that is exactly equal to the right-hand side. Yes? So this is probably the hardest one. So just, I mean, yeah, but solving this is a complete different story. How we can come up with that answer in the first place, even it's not that easy to understand these things. Okay, but when I give you a solution, you should be able to confirm that one. There is another type of problem. Let me just do that one and then we end the lesson today. And I think the lesson will be finished on time. Now I give you a solution. I want you to write me a differential equation so that this is the general solution. Yes. So let me write this one. So example. Determine. Example. Determine a differential equation whose general solution is y equals to a e to power bx. Yes? Where a and b, of course, for any, yes, a and b are constants. So can you tell me what we need to do? We want to determine a differential equation whose general solution is this. Yes?
The differential equation should be of order 2.
It should be of order 2, so that's correct, because we see two free parameters. If this is supposed to be the general solution of a differential equation, that differential equation definitely should be of order 2. Okay, but how can I find that differential equation? So that it is guaranteed that if I solve it, this would be its general solution. Yes?
Well, since it's e, don't we pretty much know that it has to be e to the power of x. So
you want to write a differential equation, an equation involving a function and its derivative or derivatives, so that when I replace y in the differential equation with this, it becomes an identity. So I think the first point is that is what you said. That's the second order differential equation. So it means that in that differential equation, at least y double prime should exist somewhere, yes? So let us calculate this to see what happens. So y prime is what? Is ab e to power bx. Agree with me? This is y prime. And if I calculate y double prime, what that happens? It becomes ab squared e to bx. Okay, then what? So let me ask you one question. In the differential equation, we don't know the differential equation, but do you expect to see the parameters in the differential equation or not? Be careful about this question. This you should be able to answer. If you solve the differential equation and find a general solution, I have erased everything. You remember this AE minus T sine T or whatever. So that solution contains the parameter A and parameter B. But if you go back and see the equation itself, you don't see any track of A and B, yes? So it means that if this is going to be a solution for a differential equation, these are playing the constant parameters, playing the role of the constant parameters. But this is clear. In the original differential equation, you shouldn't detect A and B. You understand that? But this is actually the point. So it means that I should get rid of A and B in favor of the other variables. And if I can do that, what is left for me is some relation between y, y prime, y double prime, and x. And that is my differential equation, as simple as that. So the strategy is to get rid of A and B. Assume that this is a system of equations, that everything is known to you except A and B. You have two equations with two unknowns, A and B. You want to try to find A and B. So how should I do that? Can you tell me, for example, you want to solve this differential equation. What is your first suggestion? Yes? You want to say something?
Divide.
Divide is the best thing here. Yes? I divide y double prime by y prime. This becomes ab squared e to the power of bx, agree? And then divided by ab. At least I am getting rid of many variables. So this is y double prime over y prime. On the right-hand side, a and a are gone. B and this one of them is gone. This one and that one are gone. Actually, I found b. Good. This is my b. Yes? And I want to find a. What I'm supposed to do when I find b? If you don't mind, let us put it back here. Then there would be one unknown for me, and that is a. So I put it here. Y prime is equal. Instead of a, I don't know a. Let us just write a. Instead of b, I put this expression. And instead of e to the power of bx, so I need to write e to the power of y double prime, y prime, x. Do you agree? Yes? So this is what is missing for me. For me, a is missing. Don't get confused, yes? So a is my point to calculate. So a becomes y prime times y prime. It becomes y prime squared. I divide it by y double prime, and I divide it by this expression. It was not easy at all to guess this differential equation, yes? So that is a. Okay? And now I put these things back into the equation. So what I do, I would put them in this equation. So y is equal to, instead of a, I put that expression, y prime to power 2 divided by y double prime. If you don't mind, let me bring it up and make it negative exponent. So, and then multiplied by e to power bx. Yes, is that understandable? It is a little bit, but this is what I want you to learn. I don't consider it a hard problem. as soon as you know what I am doing, I am just solving I am solving a system of equations. Don't let these things distract you. Everything, I assume, I pretend that everything is known to me except A and B. So Carl actually proposed to divide them. It was a very good thing because I was able to find B immediately, yes? And then I put B back into this equation, which is simpler than this equation. And then there is only one unknown left for me, that is A. I found A. It seems complicated, but who cares? I just care about finding A at any price. So I got it. Now I have A. I have my B. I put them back into the given equation. So instead of Y, I put Y. Instead of A, I put this whole expression, but I brought this up and made it negative. And then multiplied by e to power bx, but this is b, so it becomes e to power this one. But then you see that this is actually cancelled, yes, because this is e to negative power with the same positive power. And then you got your differential equation, which was not easy at all to guess. Yes? And now, for example, I would prefer to multiply both sides by y, and then this is my differential equation. Is that understandable? So this is guaranteed that this is the general solution for that differential equation. But the strategy was I want to get rid of a and b. Because if you remember, in a differential equation, the parameters do not appear. So it means that by this idea, I was trying to get rid of those parameters which was involved. So I would consider the hardest problem. It might be the previous problem was tedious, but it was clear. If you are patient, you were able to do that. But this problem, you need to be a little bit creative how to go back and find your solution, your differential equation. Okay, any questions? Okay, thank you very much. So I end this stream. Thank you for being with me, and I will be on Zoom if you have any questions for a while.